first slide, is my first slide visible?
Yes, yes.
So good morning, sir. Today I'm here to present a seminar on synthesis and characterization of multifunctional nanomaterials and their environmental and forensic application under the guidance of Dr. Sanjay Karvari Dupes, and is working as a research guide at Kalika Devi Arts, Commerce and Science College, Shirur, Tahsil Shirur District Bid. So my research work is mainly on nanomaterials. So why nanoparticles are most important, and what are nanoparticles? So nanoparticles are particles having the size of the order of 1 to 100 nanometers that are developed on atomic and molecular level. So why nano? Because at nano level, their properties such as physical properties, chemical, biological are different than those of bulk structure. And these properties offer various applications in various fields. So nanomaterials have numerous applications due to their quantum size effect, high surface to volume ratio, quantum tunneling. So multifunctional nanomaterials have received a great deal of attention in recent years due to their enhanced properties as compared to single-base nanomaterial. Now, multifunctional nanomaterial may possess distinct properties like electrical, magnetic, photocatalytic, and optical. So, nanomaterial, because of their properties which are different than the bulk at nano level, offer various applications. So, I have done a review, and in that review, I have found that nanomaterials have this much applications. So, multifunctional nanomaterials can be used in environmental application, SERS property, that is surface enhanced Raman spectroscopy property, antimicrobial activity, explosive detection, detection of illicit drugs which are banned, latent fingerprints, separating pollutants. So I have done a review. In that review, I have found that silane coupling agent modified nanoparticles of Fe3O4 MSN were used in controlled drug release in biomedicine. Polycrystalline and cadmium, silver and sodium dope SNNE SNSE, which is tin selenide, showed improved thermoelectric performance over single crystal SNN. Then cobalt Fe2O4 nanocrystals are used to raise the efficiency of flotation techniques for wastewater treatment. ZNO, TiO2, FeTO3, and GO2 metal oxide nanoparticles are used in latent fingerprints for small drug molecule detection. Then calcium 2, Ca2O, SiO4, DY3 dope nanoparticles were used to get finer quality of latent fingerprints on various porous and non-porous surfaces. Then cobalt ferrites and its composites like cobalt, Zn-Fe2O4 nanoferrites used as a nanoadsorbent shows maximum adsorption capacity for chromium from ternary water. Then again, I will mainly focus on copper because I have synthesized copper oxide in my research work. So copper oxide, copper Fe2O4 nanoparticles have been used for pesticide detection in blood serum. Copper oxide nanoparticles developed by green synthesis were used for enhanced fingerprint development. Cu doped sedano nanoparticles were used as a labeling agent for identifying the latent fingerprints on different surfaces using powder dusting method. There are other reports of zinc also. So ZnWO4 composites have shown enhanced photocatalytic activity for liquid and gas-phase pollutants. Reports of LaFe3O3 showing photocatalytic activity with maximum degradation of wastewater pollutants. Then similarly, reports are there also for SNO2, TiO2, WO3, Fe2O3 based sensor have been used for environmental monitoring and forensic track people explosive hazards. Then lanthanum dope, cobalt Fe2O4 are reported as magnetic absorbents for separating pollutants from wastewater. Then nano SEU Fe2O4 proved to be highly efficient for the degradation of polychlorinated biphenyls. Silver AU@AG, that is silver@gold nanomaterial, is an efficient surface enhanced Raman scattering SESE RS substrate. Silver nanoparticles have been used for explosive detection, and silver nanoprobes have reported being used for electrochemical detection of illicit drugs. Then silver@gold nanoparticles have been reported as excellent high performance SCRS substrate. Then again, copper oxide nanoparticle, which I have synthesized, shows antimicrobial activity, which can be used to treat urinary tract infection. Then silver@gold nanoparticle have been used for sensing environmental toxin and pyrin. So based on this review, I have formulated a research problem that organic dyes are harmful to human health and environment. And these dyes persist in the ecosystem for a prolonged time. So it is a type of toxic pollutants which are harmful to human health and ecosystem. Now, in this current era of developing science and technology, several crimes happen in our days. So criminals always leave fingerprints on the surfaces. So there is a need to, you can say there is a need to detect these fingerprints. So to investigate and analyze such forensic exhibits need highly sensitive, precise and appropriate tool. And this tool can be obtained by using synthesized nanoparticles. Now, what were the gaps in the existing research? So I have found that there are minimum reports are found in the literature on application of nanotechnology for environmental protection and forensic application. Nanoprobe-based photocatalysts, there are also very less reports on nanoprobe-based photocatalysts for degradation of harmful dyes, gas sensors for detection of toxic pollutants. The nanocomposite-based tools and techniques are all not developed up to the mark for analysis and studies of forensic-related exhibits, includes latent fingerprints, marks, poison. So these were the gaps. Now what I have done, based on this review, I have published a review paper on topic review on green synthesis of copper oxide nanoparticles and their environment application. So by clicking the link, we can go to the review paper also. So this is the review paper. You can see here. Yes, so this is my review. Wait, it is loading. Yes. So this is a review paper which I have published in a journal. So review on green synthesis of copper oxide nanoparticles and their environmental application. So by me and Dr. S.K. Tupesa. So in this review, I have listed the copper oxide materials which are and their application. So this was the review paper which I have published. So this is the green synthesis method. Then I have listed also in the table that these are the these different plants, how copper oxide can be different synthesized by using different plants. What is the size of the nanoparticle? What are the chemicals were used? What are their applications? So this is a review paper. And then we will not go into the detail of that. Then let's go back to the PPT. So let's go back again to the slide. Yes, so this is again the review paper. Yes, now, based on the review method, different methods have been applied for the synthesis of copper oxide nanoparticles, such as sol gel method, thermal decomposition, photochemical decomposition, sputtering, hydrochemical synthesis, precipitation method, chemical vapor deposition, chemical reduction, electro-assist chemical reduction, emulsifying method, ball milling, green synthesis. So out of this, what I have find the green synthesis method is most suitable, and that I have used. So how I have synthesized the copper oxide nanoparticle by green synthesis? How I have done? So I have used the neem particle, which is our neem, Kardu neem, Azarica indica plant extract. So 1 gram of dried neem, Azarica indica neem leaves were taken. They were washed with water. They were dried. Then 1 gram of dried neem, Azarica indica leaves powder and 50 ml of deionized water were added in a conical flask. The mixture was stirred for 20 minutes at 70 degree to 80 degree on hot plate with magnetic stirring. The light yellow brown color solution was obtained and it was filtered with Whatman filter paper. And this extract was stored at 4 degrees centigrade. Now, so this is the neem extract and this is the 0.1 ml copper sulfate solution. So 40 ml of 0.1 ml copper cupric sulfate solution was prepared and 20 ml of plant extract were taken in a conical flask. Mixture kept in an ultrasonic bath at room temperature for 1 hour. Then the color changed from greenish to brownish light color. And how the particles were isolated. So synthesized copper oxide nanoparticle solution was centrifuged at 8,500 RPM for 30 minutes. The supernatant was collected in a beaker and the brownish black colored settled copper oxide crystal were gently scratched using forceps collected into simple ones. So I have synthesized a copper oxide nanoparticle by using green synthesis method. Its characterization is remaining. I will send the sample as I was doing my pre-PhD coursework. So characterization is remaining. Now the question is why I have chosen the green synthesis method. Because it has various environmental benefits, like it is a very eco-friendly process. So reduction in toxic chemicals. So green synthesis typically avoids the use of harmful chemicals, solvent, minimizing the environmental impact and reducing the risk of pollution. Then biodegradable byproducts. So by using green tea synthesis, the byproducts of green tea synthesis are often biodegradable and less harmful to the environment compared to those from conventional methods. Then sustainable resources, renewable material, plant extract, microorganism, other biological material used in green synthesis are renewable resources, contributing to sustainability. Then lower energy consumption, green synthesis method, as we have seen, now I have synthesized, often require lower temperature and less energy compared to conventional method, further reducing the environmental footprint. Now, it is cost effectiveness, low cost raw material, neem leaves are easily available. Any plant leaves and flowers are easily available. So inexpensive precursor, the use of plant extract and their biological material is generally cost effective since this material are readily available and inexpensive. Then reduce need for purification as they are nature products. So green synthesis process tend to produce fewer impurities, which can reduce the need for extensive purification steps and associated costs. Then it is very simple process. As we have seen, I have just prepared a green extract, mix it with copper sulfate, stirred, centrifuge. So I have get the nanoparticle. So fewer steps required. The synthesis process can be simpler and involve fewer steps, reducing time and labor cost. Scalability, green synthesis method can be easily scaled up for industrial production, making them economically viable for large scale application. Then improved safety, non-toxic reagents are there, which is safe for research, reduced health risk are there. Then enhanced functional properties, so biocompatibility, medical applications. So nanoparticles synthesized using biological method are often more biocompatible, making them suitable for biomedical applications such as drug delivery, imaging, and antimicrobial treatment. Stability and their effect, so natural capping agents are there. Biological molecule can act as a natural capping agent, stabilizing the nanoparticles and enhancing their functional properties without the need for additional stabilizing. Then enhanced activity, the biological synthesis process can produce nanoparticles with unique surface chemistries and enhance activities suitable for specific application. Now, what are the application of this green synthesis copper oxide nanoparticle? So copper oxide nanoparticles, which I have synthesized, I yet to explore it applications, but antimicrobial application will be there. So they have wide range of application across many fields due to their unique properties, such as high surface area, excellent catalytic activities, strong antimicrobial properties. So copper oxide nanoparticle can act as a catalysis in environmental remediation, water treatment. Copper oxide nanoparticles are effective in degrading organic pollutants such as dyes and pharmaceutical in wastewater, photocatalytic and phenton-like processes. Air purification, they can catalyze the oxidation of volatile organic components, VOCs, and other pollutants in the air. Chemical reaction, hydrogenation and oxidation. Copper oxide nanoparticles are used as a catalyst in various chemical reactions, including the hydrogenation of nitro compounds and the oxidation of alcohols to aldehydes and ketones. Synthetic chemistry, they facilitate the synthesis of fine chemicals and intermediates in organic synthesis. Then they can be used in energy applications such as solar cell, photovoltaics. Copper oxide nanoparticles with their stable band gap nearly equal to 1.2 electron volt are used in the fabrication of solar cells to enhance light absorption and hence in the efficiency of photovoltaic devices. Then copper oxide nanoparticles can be served as a photoanodes for dye-sensitized solar cells, DSSC, contributing to better charge separation and transport. Batteries, lithium-ion batteries can also use copper oxide nanoparticle materials as anode materials. Then supercapacitor, they are also employed in supercapacitor to enhance energy storage capacity and provide high power density. Biomedical applications, which I will focus, so antimicrobial activity. So medical devices, copper oxide nanoparticles are incorporated into medical devices to prevent microbial infection due to their broad spectrum antibacterial applications against bacteria, fungi, and viruses. Wound dressing, they are used in wound dressing to promote healing and prevent infection. They can be also used in drug delivery, targeted delivery. Copper oxide nanoparticles can be functionalized with drugs and targeting the molecule to deliver therapeutics specifically to disease cells or tissues, improving the efficiency and reducing side effects. Control release, they enable the control and sustained release of drug over time. Cancer therapy, photothermal therapy. Copper oxide nanoparticles can absorb near infrared light and convert it into heat, selectively killing cancer cells while minimizing damage to surrounding healthy tissues. Then they can be also used in gas sensors, detection of pollutants, copper, which are environmental application. Copper oxide nanoparticles are highly sensitive to various pollutants such as carbon monoxide, CO2, H2S, and NO2, making them useful in gas sensors for environmental monitoring and industrial safety. Improved sensitivity, their high surface area and reactivity enhance the sensitivity and selectivity of gas sensors. Biosensors, biomolecule detection. Copper oxide nanoparticles are used in biosensors for detection of biomolecules such as glucose, cholesterol, DNA, and due to their high catalytic activity and ability to facilitate electron transport. Pathogen detection, they are improved biosensors for the rapid and sensitive detection of pathogen in clinical and environmental samples. They can also be used in electronics for conductive inks, printed electronics. Copper oxide nanoparticles are used in conductive inks for fabrication of flexible and cost-effective printed electronic devices such as tags, antennas, circuits, alternate to precious metal. So copper oxide nanoparticles can provide a cheaper alternative to silver and gold inks while maintaining good electrical conductivity. They can be also used thin films in transistors and diode. Copper oxide nanoparticles are used to create thin films for electric components such as transistor diodes due to their semiconducting properties. Optoelectronic devices, they are utilized in optoelectronic devices including photodetectors, light emitting diodes to enhance performance and efficiency. They can be also used in material science in coatings, protective coatings such as copper oxide nanoparticles are incorporated into coatings to enhance their selective protective properties such as corrosion resistance, then UV protection and mechanical strength. Then antimicrobial coatings, they are used in antimicrobial coatings for surfaces in healthcare settings and public spaces to reduce the spread of infection. Nanocomposites, reinforcement, copper oxide nanoparticles are added to polymer, metal, ceramics to create nanocomposites with improved mechanical, thermal, electrical properties. They are also functional material. They contribute to the development of functional material with specific properties tailored for advanced application. Okay. So, sir, this is my seminar. If you have any question, you can ask. Hello, sir.
Hello.
Huh?
Hello.
Huh, sir.
Hello.
Huh, sir.
There are lot of applications of copper oxide
Yeah.
nanoparticles, but on which you are going to focus?
Antimicrobial and forensic latent fingerprint.
Okay.
आता I have synthesized, sir, but as the PhD coursework was up to the 3rd of June, so I have not sent them for characterization. I'm going to send and I'm going to again synthesize the new compounds.
Okay. Okay.
Okay, sir, I will end the meeting and I will check whether it is recorded or not.